Inside enormous factory halls where molten aluminum glows like liquid fire and machines move with relentless precision, Tesla quietly rewrote one of the oldest industrial processes in the modern world, not by improving engines, not by refining batteries, but by dismantling the very logic of how cars have been built for more than a century. For generations, automotive manufacturing followed rules that seemed unchangeable. Cars were not created as single structures. They were assembled, piece by piece, layer by layer, through a complex choreography of machines, welds, and human oversight. Tesla looked at this tradition and saw not stability, but inefficiency. And instead of optimizing the system, it chose to replace it entirely. This is the story of the Gigapress, a machine so powerful and disruptive that it transformed how vehicles are built, how factories are designed, and how the future of manufacturing itself may unfold. The old way of building cars. For more than 100 years, the body of a car began its life as flat sheets of metal. These sheets were stamped again and again into individual components, each shaped for a specific role within the vehicle's structure. By the time a single car body was ready for assembly, it often consisted of 300 to 400 separate stamped parts, each produced by different presses, dies, and tooling systems. These parts did not naturally fit together. They had to be aligned with extreme precision and then permanently joined. This is where welding dominated the factory floor. Thousands of spot welds were applied to a single vehicle, binding metal to metal at countless points. Each weld required time, energy, inspection, and calibration. Every weld also introduced a potential weakness, a place where stress could concentrate, corrosion could begin, or fatigue could develop over years of use. As the body moved through the factory, it passed through dozens of assembly stages, each one adding complexity. Robots lifted, positioned, clamped, welded, and released components in carefully timed sequences. Conveyor systems stretched across vast distances, moving partially completed vehicles from one station to the next. The factory itself grew larger and more complex with every new model, consuming massive amounts of floor space simply to manage the flow of parts and processes. This system worked, but it was slow to scale, expensive to maintain, and difficult to change. Tesla's radical question. Tesla did not inherit decades of legacy factories. That freedom allowed its engineers to question assumptions others took for granted. They looked at traditional assembly lines and asked a deceptively simple question. What if most of these parts never existed? What if instead of welding hundreds of components together, a car's structure could be created as a single piece? This question led Tesla away from stamping and welding and toward a manufacturing process that had never been applied at this scale in the automotive world: high-pressure aluminum die casting. The birth of the Gigapress. Die casting was not new. It had been used for decades to produce small, complex metal parts with high precision. Engine housings, brackets, and electronic enclosures were commonly made this way. But casting an entire car structure was considered impossible. The molds would be too large. The cooling would be uneven. The defect rates would be unacceptable. Tesla decided to attempt it anyway. To make this possible, Tesla partnered with Italian manufacturer IDRA, pushing die casting technology far beyond its previous limits. Together, they designed a machine so large and powerful that it required a new category altogether. Its clamping force would be measured not in hundreds of tons, but in thousands. The machine became known as the Gigapress. What a Gigapress does. A Gigapress is a high-pressure aluminum die casting machine capable of applying up to 9,000 tons of clamping force. Inside the machine, aluminum alloy is heated until it becomes molten. This liquid metal is then injected into a hardened steel mold at extreme speed and pressure, filling every cavity in milliseconds. As the aluminum cools and solidifies, it takes the exact shape of the mold. When the mold opens, a single massive vehicle structure emerges, complete, precise, and ready for installation. What once required hundreds of stamped parts and thousands of welds is now created in a single machine cycle. The scale inside Tesla's factories. Gigapresses dominate Tesla's gigafactories both physically and operationally. Each machine weighs hundreds of tons and stands several stories tall. The foundations beneath them are reinforced to absorb immense forces generated during each casting cycle. Molten aluminum is delivered through insulated channels, carefully controlled to maintain precise temperature and composition. Robotic arms remove finished castings seconds after each injection, while automated systems prepare the mold for the next cycle. A single Gigapress can produce a large structural casting roughly every 90 seconds. Over the course of a day, this adds up to thousands of components, produced with consistency that traditional assembly lines struggle to match. Factories that once required endless rows of welding robots are now organized around a handful of casting machines. Why one piece is stronger than many? Traditional car bodies behave like patchworks. Each welded joint introduces a discontinuity in the structure, a place where forces change direction, where stresses accumulate, and where fatigue can begin. Over time, these weaknesses add up. Gigapress castings eliminate these discontinuities entirely. Instead of hundreds of parts joined together, the structure behaves as a single, continuous form. This dramatically increases rigidity and improves crash performance, as impact forces are distributed evenly throughout the structure. Tesla developed specialized aluminum alloys designed specifically for large-scale casting. These alloys cool in a controlled manner, creating a uniform grain structure across the entire component. This level of material consistency is nearly impossible to achieve with welded assemblies. The cooling and defect challenge. Casting components of this size introduces serious risks. As aluminum cools, it shrinks. If cooling occurs unevenly, cracks form. If gases become trapped, internal voids weaken the structure. To solve this, Tesla engineered molds with precisely controlled cooling channels. Vacuum-assisted casting removes trapped gases before solidification. Thermal sensors monitor temperature across the mold in real time, while automated systems adjust parameters instantly if conditions drift outside acceptable limits. This level of control allows Tesla to maintain extremely low defect rates, even while producing some of the largest aluminum castings ever used in automotive manufacturing. Simplifying the factory itself. The true impact of the Gigapress is felt across the entire factory. By reducing hundreds of parts into one, Tesla eliminated entire welding departments. Robot counts dropped dramatically. Conveyor systems shortened, tooling complexity decreased. Factories became simpler, faster, and easier to scale. New production lines could be installed in months rather than years. Design changes could be implemented without reworking thousands of weld points. Manufacturing shifted from rigid mechanical systems toward flexible, strategy-driven layouts. The structural battery revolution. Tesla extended the Gigapress concept further by integrating the structural battery pack. Instead of treating the battery as a separate module, Tesla made it part of the vehicle's load-bearing structure. Gigapress castings form the front and rear sections of the car. The battery pack becomes the central structural element. Together, they form a single rigid chassis that is lighter, stronger, and simpler to assemble. This approach reduces weight, improves efficiency, and further reduces the number of parts required to build a vehicle. Why the industry struggles to follow. Many automakers recognize the potential of the Gigapress immediately, but adopting it is not easy. It requires redesigning vehicles from the ground up, rebuilding factories, developing new alloys, and accepting enormous upfront costs. Legacy manufacturers are constrained by decades of existing infrastructure. Tesla, unburdened by that history, was able to take risks others could not. The risks Tesla accepts. Gigapress manufacturing is powerful, but unforgiving. A defect affects an entire structure. Tooling is expensive and slow to modify. Design mistakes are costly. Tesla accepts these risks in exchange for speed, scale, and long-term efficiency. It is a high-stakes strategy, but one aligned with the company's aggressive approach to innovation. A shift that goes beyond Tesla. The Gigapress is more than a machine. It represents a fundamental shift in how complex systems are designed. Instead of optimizing complexity, Tesla removed it. What took the automotive industry a century to refine was rewritten in a single decade. So now you've seen how Tesla builds entire cars using Gigapress machines, replacing hundreds of welded parts with single cast structures and redefining the future of manufacturing. Is this the future of all vehicles, or a risk only Tesla can afford to take? Let me know your thoughts and join me for the next story of engineering reshaping the modern world.